Hey guys, hope you're all doing good. Sorry for the delay in uploading the class. The internet today has not been cooperating, neither has my phone, but no worries, because since I already gave you your chemistry assignment for the week, what you can do is check this video out today and start working on these exercises tomorrow. I have been receiving a lot of your emails regarding the chemistry class, and that's good to know that you've been doing that. It's bad news for me because at the end I have to sit down and correct a whole bunch of work, but it's all right. We'll do it. So today's topic is actually on page 430 of your Algebra and Trigonometry book. We're actually going to do two examples. And I know that I've been taking this section a lot slower than usual, but this is trigonometry and it can be a little bit trickier, so I'm going this slow on purpose. So on page 430, we're going to look at example 7, which I wrote on this side of the board, and example 8, which I wrote on this side. Now you're going to kind of see me go back and forth, in and out, because my book is over there, and I can't seem to find a closer place to it, and because I left my marker over there. So give me 1 second. You missed me? Yeah, you know you missed me. All right, guys. So, second class of Algebra and Trigonometry, and the topic is linear and angular speed. Now, linear and angular speed in trigonometry or in physics, excuse me 1 second, are used to measure how particles move either in an angular speed or in a straight line, depending on what kind of movement we're talking about. So, to do that, we have a couple of formulas. First, we're going to review the arc length formula. The arc length formula is S equal R times Z, where Z is in radians and R was the radius. But another way to talk about arc length is by using the circumference formula, which is 2 pi r. So S equals R times Z and S equals 2 pi r is actually one and the same. Now, the reason I have it is for the example that we're going to work on now. The other formulas that we're going to be working on today is linear speed, which is V equals arc length over time, and the angular speed, which is the central angle over time. So what I'm going to do is I'm going to explain this example very quickly, and then, ladies and gentlemen, you guys are going to, I'm going to leave this on the board and and then give you a couple of seconds to look at it or whatever, and then I'm gonna go and work on the next example, and my book is over there, so again, pardon me. And what we're going to do then is at the end of the video, I'm going to assign you the exercises that we're going to be working on. So let's get started. Let's get down to the nitty gritty. And the problem says, example number 7, page 430, says finding linear speed. The second hand of a clock is 10.2 centimeters long. So this hand is actually 10.2 centimeters long. Here is my representation of a clock. If you don't like it, you can always draw it nicer in your notebooks. It's 10.2 centimeters long. Find the linear speed of the tip of the second hand as it passes around the clock face. So, to actually find how fast the second hand is moving around the clock. Remember that time, we're going to use time as minute, and that's basically the unit that we're going to use at least for these two exercises. So the first thing that we need to find is the arc length. Now I can't really find the arc length the way we did it before because I have a radius but I don't really have an angle. So since I don't have an angle, I can actually use the other formula, the circumference. So once again, I'm gonna use arc length, but I'm not gonna use the first one, which is what we did in the previous section, because I don't have an angle given to me here. All I have is a radius. But that's not a problem because I can use this one. So what you're going to do is you're going to find the arc length by using the circumference. S equals 2 times pi times r. And pi is 3.14, so you are going to need a calculator for this. And you're going to say 2 times 3.14 multiplied by the radius, which in this case is 10.2. Alright, so I'm going to let you look at that real quick so you guys see what I did. And don't miss me for too long because I'll be back. And I am going to be back in the next 5 seconds. So what you're going to do is you're going to multiply 2 times 10.2, which is actually going to be 20.4 pi. Now the reason, if you have a calculator, you can go ahead and let me start that again. So you're going to multiply 2 pi times 10.4, which is your radius, and 2 times 10.4 is 20.4, so we have 20.4 pi. That's equals 20.4 pi. Now, if you have a calculator, you can just go ahead and multiply 2 times 3.14 times 10.2, and that's going to give you the direct answer. In that case, we have 20.4 times pi, and that would be the arc length. But to find the linear speed, I have to divide that by time. So, to find the linear speed, which is this one, we have V equals, now we know the arc length. The arc length is 20.4 pi, and we're going to divide that by time. Now, the second hand is actually the minutes. So what we're going to do is we're going to divide it by t, and since t, or the second hand is the minutes, instead of writing t, we're going to write 60. So you're going to multiply 20.4 times 3.14 in your calculator and divide that by 60, and that's going to give you the velocity, which is approximately 1.068 centimeters per minute. Okay, so once again, this is what I did. I'm looking for the linear speed, and the linear speed is given to me by the formula V equals arc length over t. Okay, now the arc length, I can't use the r times z formula because in the exercise I don't have an angle. So I multiply 2 pi times r. Now why do I use 2 pi? Because remember that the movement is circular, and one full rotation around a circle, we call it 2 pi. So that's why we use 2 pi r. Anyway, S equals 2 pi times r, which is 10.2. So you multiply 2 times 10.2, which is 20.4, and you bring down the pi symbol. Then what you're going to do after that is you're going to divide it by the time. Now, since it's per minute, because the question is asking you, or telling you to find the linear speed of the tip of the second hand as it passes around the clock face, the second hand being the minute hand, we're going to divide that by 60 because 1 minute equals 60 seconds. So you multiply 20.4 times pi times 60, and that equals 1.068 centimeters per minute. So go ahead, look at that real quick. I'm going to step out and give you a couple of seconds so you can take a look at it. The good thing about this video is you can pause, rewind, and in worst case scenario, you can ask me if you have any questions. So without further ado, I'm going to give you a couple of seconds, then I'm going to erase it so we can start with example number 8. And I'm going to give you 1, 2, 3, 4, 5 seconds, and here we go. I'm erasing it. And we're going to go to page 430, example number 8. Now, example number 8 is actually talking to us about angular speed. Now, for angular speed, we need the central angle. And example number 8, which is on page 430 of your textbook, so you can follow along later when you're watching the video. It says the blades of a wind turbine are 116 feet long. So think about one of these windmills. And it says that this is about 116 feet long. And it says that it moves 15 radians per minute. So every minute, 15 revolutions, pardon me. So every minute it moves 15 times is what it's saying. Okay, so that's how fast the wind turbine is moving. And they're asking for A, to find the angular speed of the propeller in radians, and then B to find the linear speed. Now, angular speed, we said, is the central angle over time. Okay, so let me let you look at that real quick. Familiarize yourself with it, and then I'll be back in a minute to continue with the explanation. Okay, the angular speed. Remember that the angular speed is actually the central angle divided by the time. Now, what are we gonna do? First of all, it's asking for us to give the angular speed in radians. So the formula says the central angle over time. But they want it in radians. Now, I already explained in the previous example that one full rotation around the circle is 2 pi. So what we're going to say is V equals 15, because 15 is the revolution, multiplied by 2 pi, because one revolution or one rotation around the circle is actually 2 pi. Over the time, now it says per minute, so we're also going to use 60. And what we're going to do is take a look at that real quick, and then you can more or less have an idea of what we're going to do in that case. Okay? So it's actually, and I made a mistake here. Let me fix that real quick. So once again, it's 15, because that's the amount of revolutions in 1 minute. 2 pi, because they want the answer in radians, and one full rotation around the circle was 2 pi. So what you're actually going to do is simply say 15 times 2 pi, and that would equal to 30 pi, and in 1 minute, so your answer is actually V equals 30 pi per minute. Simple, very easy. Take a look at it again as I step out. Okay, so once again, we just did example 8a, and it says the blades of a wind turbine are 116 feet long. The propeller rotates 15 revolutions per minute. So this is my representation of that. If you can do it better, then do it better, because this is pretty ugly. But anyway, 116 feet long, and every minute this thing rotates 15 times. So they want us to find the the angular speed in radians. So what we're going to do is it's central angle over time. They're not telling us to do anything else. They just want us to kind of like give us the speed in radians. So 15, because 15 is the revolution. 2 pi, because every time you go around the circle, one time is 2 pi. So you multiply 15 times 2, which is 30, bring down the pi sign, and then the time is actually 1 minute. So it's actually 30 pi divided by 1, and your answer is 30 pi radians per minute. So go ahead and take a look at that real quick. I'm going to leave it there for a couple of more seconds. I'm going to step out of the camera. Don't miss me for too long. And then we're going to do the next example, which is to find the linear speed. Okay. And I'm back. So here we go. Linear speed. Same problem, but we're looking for linear speed. Now we know the formula for linear speed is V equals the arc length over time. Well, the arc length we know is V equals S, which is the arc length, which equals the radius multiplied by Z over time. Now in this exercise, we have the turbines. They kind of move like this, and this is 116 feet. So we do have a radius, and we do have a central angle or a degree. Now what we're going to do is we're going to say 116 is the radius. We found the z, we found the central angle, and the angle was actually the 30 pi that we got from the previous one. So let me write it here so you guys know that this was the answer for A. So we're actually going to multiply that by 30 pi. And our time, which is actually 1 minute. But since I am, so it's 1 minute, excuse me. So it's actually 1 minute. Pardon me. Again, my book is kind of far away, so you see me kind of coming and going, but I hope it's not interrupting you. Anyway, I'll just explain it again in case there was any doubts. And the time, which is 1 minute. So once again, we're looking for the linear speed, which is arc length over time. Arc length, we know, is actually radius times the z. We have the radius, which is 116. We found z from A, from the 30 pi that we got before. We multiply them and we divide them by 1. So basically you're multiplying 116 times 30 times pi, and your answer is approximately 10,396, if I'm not mistaken. 10,933. There you go. Completely off. 10,933 feet per minute. 10,933 feet per minute. Okay, so once again, ladies and gentlemen, very quickly, what we did was we found the, for A, we found the angular speed, and the angular speed was the central angle divided by time. In this case, the central angle was the 15 multiplied by the 2 pi, and that gave us 30 pi, and then we take this 30 pi to find the linear speed, and we actually plug it into this formula. Arc length is the same thing as saying radians multiplied by z. Radius multiplied by z, radius was the 116. The z was the 30 pi that we got from our previous exercise. Multiply 116 times 30 times pi, and your answer is 10,933 feet per minute. So that's it. We're done. That's it. That's the lesson for today. So what are you going to do now? Well, you're going to answer on your checkpoint, page 430. You have 2 checkpoint problems, well actually 3, because the second problem is A and B. But basically you're going to do checkpoint page 430. You're going to do the same thing you did for the previous example. You're going to take a picture of them. You're going to use the app camera scanner. You're going to email them to me. And then on Friday, I'm going to upload, God willing, I'm going to upload the other class for algebra and trig, in which case we'll be finishing the section. So ladies and gentlemen, that's it. We're done. It's over. That's the second class. Hope you guys enjoyed it. And if you didn't, well, I mean, it's because you don't enjoy math, but that's not really my problem. That's yours. No, I'm kidding, guys. If you do have any questions, any doubts, you can text me like a lot of you have been doing. You can email me. Again, identify yourselves when you text me, just in case. We will have the virtual classrooms hopefully again on Friday. So guys, this is it. Stay safe. And this is your favorite teacher. Don't deny it anymore. You know I'm your favorite teacher, right? Take care. Bye.